In order for us to solve this system of simultaneous equations using Cramer's rule, we first of all have to write these equations in matrix form. The first matrix will consist of the coefficients of these unknowns. So we realize here x has a coefficient of 1. We shall write it here, 1. This y has coefficient of -2. We write -2 here. And this is having a coefficient of 1. We write 1 here. In the second simultaneous equation, the coefficient of x is 2. We write 2 here, below where we had written the other coefficient for x. Then you realize we don't have y here. So that means where we were supposed to write the coefficient of y, we write 0 because it's absent. And then the coefficient of z here is +2, write 2 here. In this third simultaneous equation, we don't have x, so we shall substitute it. We shall write 0 here, where it was supposed to be written. This y has a coefficient of 1, we write it here. And the coefficient of z is 3, we write it here. Then the next matrix is that matrix of unknowns, or the variables, which are x, y, and z. We shall write them in column form. The first one will be x, y, and then z. That one is equal to the quotients matrix, which is a matrix consisting of these quotients here. So we have it there. Having done that, the next thing now is to start solving for x, y, and z. So we shall say x is equal to, now for us to solve that, we need to come up with some determinants for this 3 by 3 matrix, the coefficient matrix, which we shall use in solving. We shall have to write it on the numerator and on the denominator side. But on the numerator side, we need to adjust by replacing these elements representing the coefficients of x with the elements which are in the quotient matrix. So we are supposed to write the whole of this down here, but these elements that represent the coefficients of x will have to be replaced with this, like that. These are the elements for coefficients of x. We have replaced them with the elements that are for the quotient matrix. These others, you leave them the way they are. So we shall have -2 here, 1, 0, 2, 1, 3. Now we shall divide by the determinant of this matrix, but we shall not alter it in any way. So we shall divide it by this, the way it is, the determinant of this matrix. There are two ways of working out the determinant of a 3 by 3 matrix. I will start with the first one, which involves the use of cofactors. Now, to achieve that, we shall take these elements in the first row and we use them as scalars. Then we shall come up with 2 by 2 minor matrices using these elements, as I will show you in the next few minutes. So if we start with this 0 here, let's write it as a scalar. And then if you cancel the row and the column on which this 0 is, you realize that the elements that will remain are 0, 2, 1, 3. After you cancel the row and the column on which this 0 is, these elements are the ones that remain 0, 2, 1, 3. So you'll use them to form a 2 by 2 minor matrix as shown. And we shall need to get its determinant. That's why we have this bars like that. Now, as I said, we are going to use these elements and we write them as scalars. So the next one to use is this one, but you must reverse the sign for this second element. You must reverse the sign for this second element. So we shall have minus, and then you take this element. You notice it's -2, so we have -2 there. After that, cancel the row and the column on which this -2 is. If we cancel the row and the column on which it is, the elements that remain are 8, 2, 5, and 3. So they will form a minor matrix of order 2 by 2. And here it is. We have 8, 2, 5, and 3, like that. Then after that, you bring this one together with the sign. So we'll have +1 or +1 into, cancel the row and the column on which this one is. So if we cancel the row and the column on which it is, the elements that remain are 8, 0, 5, and 1. We form a minor matrix using them. I need to point out here that when you are writing these scalars, 0, -2, and 1, you realize that we did not change the sign for this one. Here we reversed the sign. Here we did not change the sign. So that's the rule. Now divide all that by, we do the same on this denominator side. Take the first row, the elements in the first row, you use them as scalars as we have done here, and then you will cancel the row and column on which they are, get a minor matrix. So if we start with 1, we shall write 1 down here into, so if we cancel where this row, where the row where this 1 is and the column, what remains is 0, 2, 1, 3. So they will form a minor matrix like that. Reverse this sign. It's always a must that you reverse the sign for this second element. So we shall have -2. Then cancel the row and the column on which it is. So if we cancel the row and the column on which it is, the elements that remain are 2, 2, 0, 3. And then +1 into, cancel the row and the column on which this one is, the elements that remain are 2, 0, 0, 1. So they will form a minor matrix. Now let's simplify this. So that's equal to 0, this 0 here, into, remember we are getting a determinant of this matrix. That's why we have these bars here. So we have 0 times 3 minus 1 times 2 minus -2. The resultant sign is a positive, so we shall have +2 into 8 times 3 minus 5 times 2. Then +1 into 8 times 1 minus 5 times 0 over, we do the same on the denominator. We have 1 into 0 times 3 minus 1 times 2 minus -2. That results in a +2. So +2 into 2 times 3 minus 0 times 2. Then +1 into 2 times 1 minus 0 times 0. Like that. If you simplify that further, you will get this being equal to 0 into 0 minus 2 plus 2 into 24 minus 10 plus 1 into 8 minus 0 over 1 into 0 minus 2 plus 2 into 6 minus 0 plus 1 into 2 minus 0. Simplify that, you will get it being equal to 0 into -2 plus 2 into 14 plus 1 into 8 over 1 into -2 plus 2 into 6 plus 1 into 2. If you simplify this, the numerator will give you 36 over, the denominator gives you 12, and that gives you 3. So that means the value of x is equal to 3. We do the same for y. We shall work it out in this similar manner, but you will notice that we shall have to take these elements for the quotient and substitute them where we have the elements for the coefficients of y here. So on the numerator, we shall have this and this the way they are, but for these ones, okay, these ones will come and replace this. So we shall have it like this. Y is equal to 102,085,123. So if you compare it with what we have up here, you realize that I've substituted these elements, which consist of the coefficients of y with these ones. So we substitute the coefficients of the variable we are looking for with the quotient elements. Then you divide by the determinant of this matrix. The denominator is not altered. You just take the whole of this coefficient matrix, you place it on the denominator and get its determinant. Now, for this one, I'm going to use the other method for getting a determinant. So what we do in this second method, just take these elements the way they are, you write them down here, excuse me, and then you duplicate it again. So we have written these elements twice. These elements have been written twice. We have the first set here, and then the second set side by side. Having done that, then you come up with three primary diagonals using these elements, and then another primary diagonal here, and another primary diagonal. Then, having done that, you come up with three secondary diagonals using these elements, and then the ones following it, and these other ones also. So we used the first three elements on top here to guide us on the primary diagonals we should come up with, and then the remaining three elements assisted us in getting the three secondary diagonals. So having done that, then multiply these elements, or get the product of these elements plus the product of these elements plus the product of these elements minus the product of these elements minus the product of these elements minus the product of these elements. So we shall say that is equal to, excuse me, 1 times 8 times 3, that's the product of the elements of the first diagonal, plus the product of the elements of the second diagonal, which are 0 times 2 times 0, plus the product of the elements in the third primary diagonal, 1 times 2 times 5. Then minus the product of this first second diagonal, which is 1 times 2 times 5, minus the product of these elements in the second secondary diagonal, which is 0 times 2 times 3, minus the product of the elements in this third secondary diagonal, which is 1 times 8 times 0, divided by 12. Why are we dividing by 12? It's because you realize here we are looking for the determinant of the same matrix that we had used up here. We had used the same matrix here, and we have calculated it. You realize it boiled down to 12. So instead of us working it again, we have just borrowed the determinant for that denominator matrix direct, and we have just used it here to save time. So this gives us 24. So we have 24 plus 0 plus 10 minus 10 minus 0 minus 0 over 12. 24 plus 0 plus 10 plus, minus 10 plus 0 minus 0 is equal to 24 divided by 12, and that gives you 2. So that means the value of y is equal to 2. So here I've used the second method of getting a determinant of a 3 by 3 matrix. Then we now go and work for z. We shall do the same. We shall come up with such a kind of calculation, but these third elements in this third row here will have to be substituted by the coefficient matrix. The first and the second one will remain the way they appear up here. So we shall maintain these elements and these ones, but for these ones, because they are the ones representing the value z that we are looking for, it means we shall substitute them with this. So it will look like z is equal to 1, 2, 0, negative 2, 0, 1, and then you realize these elements which are here, which represents the coefficients of z, have been replaced by the elements which are in the quotient matrix. Then when you do that, you divide by the determinant for this matrix. So you divide by that. Now let's work using the first method of cofactors to get the determinant on the numerator side. So we shall say that's equal to, we said you use these elements as scalars, and then you mentally cancel the row and the column on which an element is, get a minor matrix of order 2 by 2, you will find that the determinant. So we take 1, which I've written here, then cancel the row and the column on which this one is. What remains are elements 0, 8, 1, 5. You use them to form a 2 by 2 minor matrix that we want its determinant. So that is the one. Then we take this element, reverse the sign. So we shall have minus negative 2 into, if you cancel the row and the column on this one, on which this element is, you cancel this row and the column on which it is, you remain with the elements 2, 8, 0, 5. You want the determinant of that minor matrix, and then plus 0 into, cancel the row and the column on which this 0 is, you remain with the elements 2, 0, 0, 1. I have to repeat that we agreed that we don't reverse the sign for this element, but we reverse the sign for this element. We also don't reverse the sign for this element when we are using them as scalars outside here. So that one will be all over 12 again. We have written 12 because we have worked this determinant above when we are working for x, and therefore we know it's 12. So let's simplify the numerator. We shall have 1 into 0 times 5 minus 1 times 8 plus 2 into 2 times 5 minus 0 times 8 plus 0 into 2 times 1 minus 0 times 0, all over 12. So that is the same as 1 into 0 minus 8 plus 2 into 10 minus 0 plus 0 into 2 minus 0 over 12. When you simplify that, you will get it giving you 1 into negative 8 plus 2 into 10 plus 0 into 2 over the denominator, which is 8. And if you simplify the numerator, you will get it giving you 12 divided by the denominator, which is 12, and that gives you an answer 1. So that means that the value of z is equal to 1. So we have so far solved for x, y, and z. So we can say therefore x is equal to 3, y is equal to 2, and z is equal to 1. Thank you.